Morning. Welcome in a new class of this reactive intermediate series and the carbocation. First of all, sorry for the last audio problem in last class. Okay, those audio, there is some little audio problem in last class, but if you carefully listen, uh, you can get that. Okay, you can understand. So do a little effort to learn something new or to practice a lot of problem. Let's start with this class. So in last class, we have discussed some formation of carbocation, and thereby we have seen some reactions of carbocation. We have seen the three major ways to form carbocation. And last part that was remaining is diazotization of primary amine. So let's start with that. Diazotization of primary amine. So in this carbocation segment, we have seen structure, stability series, and after that rearrangement, ring expansion, contraction. There are few exceptions, few special problems. After that, the three ways to form carbocation. Okay, first one and second one we have discussed in the previous class. If you missed that, before continuing this class, first refer to that. Okay, that video. And now we are going to discuss the third one, diazotization of primary amine. And till now, we have not entered the reactions where carbocation is involved. Actual reactions, important reactions where carbocation is involved, we have not discussed yet. Okay. So after this segment, we are going to discuss them one by one. In diazotization of primary amine, the concept is there is a reaction called diazotization reaction. What happens here? 1 degree amine is taken, suppose RNH2. This is primary amine because nitrogen is attached with one carbon only, so 1 degree. And the reagent is NaNO2 HCl. And temperature is low, generally 0 to 5 degrees Celsius. These two reagents, NaNO2 and HCl, inside the reaction, they form nitrous acid, HNO2. So if in any case in the arrow, sirf only HNO2 or HONO, this is HNO2 only. Okay, sometimes you get confused what is HONO. That is HNO2 only. So don't get confused. These are basically this reagent NaNO2 HCl. So this ultimately react and convert RNH2 to R into Cl. Cl from this and NH plus Cl minus. So this is diazonium chloride. This is nothing but diazonium chloride. Diazonium chloride. Okay. Now this diazonium chloride, here N2 plus Cl minus. If the carbocation is stable, then what happens? This bond breaks and nitrogen is removed, minus N2. Okay, Cl minus is just an anion, just a counter ion to balance the charge. So here R plus is formed. Okay, if we give polar protic solvent in this case, like water H2O, then it will act as nucleophile again. Okay, so ROH will form. Okay, and in R plus, if rearrangement or ring expansion, contraction, etc. possible, ring expansion, ring contraction, rearrangement if possible, then it will occur after that. If nucleophile present, then nucleophile will attack. Otherwise, elimination will occur. We have practiced a lot of problem regarding this in the last class, right? So let's proceed with some examples. Okay. Let's discuss a little bit mechanism first. Okay. NaNO2, before example, let's draw mechanism of this process. NaNO2, we are adding HCl, H plus Cl minus. Okay. So Na plus and Cl minus. So HCl will form. HCl, this is exchange reaction kind of, plus HNO2 is formed. You can see H plus NO2 minus. So HNO2, the structure of HNO2 is N double bond O, OH. That's why HONO is written sometimes. Okay. Now, as this is acidic medium, HCl is acid. So this is acidic medium. In acidic medium, what happens? This OH lone pair attacks here. Okay. Now, OH2 plus will form. O double bond N. Sorry. OH2 plus will form. Okay. Water will remove. Then N double bond O. Or we can say this can occur like this. So this can push the water to remove. So N triple bond O plus. This cation, this is actually the electrophile or the cation, intermediate cation. This is nitrosonium ion. Nitrosonium ion. Nitrosonium ion. Okay. So NaNO2 HCl, this forms HNO2, and HNO2 in the acidic medium gives us nitrosonium ion. And what we are adding? We are adding RNH2, right? So we are adding RNH2. What will happen? Nitrogen will simply attack, right? So R N H H N double bond O. Simple. Now what happens? A tautomerism kind of thing occurs. First what happens? This like tautomerism, nitrosoximino-tautomerism kind of thing. R N H H double bond, and now sorry, this hydrogen will not be there. Yes, double bond N OH, and this nitrogen is positively charged. This nitrogen is positively charged. Now what happens? Proton exchange occurs. This OH will take up this proton and neutralize the positive charge. R N double bond N OH2 plus. Okay. Now this lone pair attacks here. Water is getting removed. R N triple bond N plus. So now you can see this is nothing but Rn2 plus, right? Rn2 plus. The counter ion will be Cl minus. This is our diazonium chloride. So this is the simple, not so much simple, but yes, it's simple, just proton exchange and nucleophilic attack. So this is the mechanism of diazotization of primary amine. Now let's do some example. Okay. Question. First try yourself and after that watch the solution. Question is NH2. Okay. Now as reagent, suppose I am giving just HONO. You have to recognize this is diazotization reaction. Try yourself and after that watch this video again for the solution. Okay. Then here N2 plus N2Cl. Okay. Then this can remove. So this cation will form. Now what will happen? This is 5-member ring. Okay. So if we there is a possibility of ring expansion, right? 5-member ring, and there after that CH2 plus. So ring expansion. This will give simple. If you can't write in a proper way after ring expansion, just do numbering it. Suppose 1, 2, 3, 4, 5, 6. So 6-member ring. Draw 6-member ring and give random numbering 1, 2, 3, 4, 5, 6. What happens? 2, the bond 2 is getting vacant. The valence is vacant. So 2 will get C plus, carbon positive. And the one carbon has, C1 has one methyl group. Now no nucleophile is given. As no nucleophile is given, then take alpha hydrogen and make more stable alkene. So this positive charge has alpha hydrogen has 3 position, alpha hydrogen has 1 position. But alpha hydrogen in 1 position will give more hyperconjugated or more stable alkene. You can count, you can try possibility from 3 also and count the number of hyperconjugation. You will find that that will be less. Okay, so this is our final product. Okay, hope you understand it. If in any exam, if you do not find this, then alternatively you can find this. Sorry. This is one mistake I have done actually. I'm sorry for that. One little mistake. The carbocation formed here, you can see it is 2 degree. Here another possibility is there. This hydride can undergo hydride shift and this will give a 3 degree cation. So our final cation will be this, okay, not this. Now it has alpha hydrogen like this. You will find that this right side or left side carbon, from this side you will get more stable alkene like this, or both are same like this. But alternatively, if you do not get these in option, then alternatively you can get this also in option. So if this is more accurate answer, more perfect answer, but if these are not sorry, sorry for the problem. So let's continue what we were discussing from there. So finally we are getting okay. So finally we are getting this carbocation. So from here alkene can form. Otherwise, if this alkene is not in option, then you can alternatively find this in option OH2, because in the mechanism, if you notice, one water molecule was getting removed. So this water molecule can attack there, and this you can get another product. Okay. So I hope you have understood this, and I am giving you some similar kind of problem, and I am writing the product also. You have to try yourself. Okay. Question, homework kind of thing. Methyl NH2 AC1HNO2, second water. So you have to do yourself and match with the answer. Here the answer will be, just try yourself. First make carbocation, and if rearrangement is possible, then do that accordingly. And then next question. Here the bridgehead concept of bridgehead, have to consider that. Okay, you have to take care of any shift. If it is giving methyl shift or hydride shift, if it is giving bridgehead carbocation, then that will not be feasible, right? NaNO2HCl, second water. First step NaNO2HCl, second water. Here the product will be OH2. Okay. Third question. Question is a little tricky. CH3, C2H5, H, OH. It is giving just ammonia, and after that A. After that it is given NaNO2HCl, then water. Similar kind of reaction. You are getting, it is said that you are getting B plus C. And now question is, write structure of B plus C, B and C, and relation between B and C. Relation between B and C. Relation between B and C. So try yourself. OH NH3, with NH3 OH will become NH2. A will become just NH2 over there. Okay, in the OH position. After that B and C will form. So you have to proceed accordingly. First, do one thing. You know that after A, the reaction will give a carbocation, and after the carbocation is forming, OH, we all know carbocation is planar. Suppose this carbocation is planar carbocation, right? So from above the plane side, this can water can attack, the below face side water can attack. Okay, so this will give product like this. If methyl above, OH below, plus if OH attack from above side, so in above side O will be there above the plane, and below side it will be methyl. Eventually these two are same compound, but here these two will be different compound. So just write the structure of B and C. First, for your convenience, you can convert it to flying wedge projection, and after that you can tell the relationship. Okay, just I am writing the answer. Do yourself and match with this. Product will be OH, and relationship will be enantiomer. Enantiomer. Okay. And last tricky question from this concept. I will solve this for you, but first try yourself. It is the most difficult question I am giving to you in this segment. Okay. Your compound is like this, NH2, HNO2, water. Okay. So what will be the final product? Let's start. First, we all know in the position of NH2, we will get one carbocation, right? After N2 removal, we will get one carbocation. Now, it is a bridge kind of compound. Bridge kind of compound. If we can write this bridge, you can notice this two position is bridging position. Okay. Now, it is 3-1-1 bridge. Here 3 carbon, 1 carbon, and 1 carbon. So 3-1-1 bridge. So 1, 1, and 3. 1-1-3 bridge, right? And after bridgehead position, next to bridgehead position, we have one methyl group, and here it is cation. Now this is very strange system. Okay. Now here ring expansion occurs. Ring expansion in bridging system. Maybe you have not seen, or maybe in very less example you have seen this kind of example. So if this bond shift here, what we will get? We have to reduce the ring strain. This is 1-1-3 bridge. Okay. So 1 bridge, actually 1 bridge, there are 2. So these are very much unstable. If we can increase like 2-1-2 kind of, so 3-member ring is 3 is stable enough. So we will try to balance the strain. It is more strained, it is less strained. We have to balance that. Okay, to balance this, to reduce the ring strain of this is very much strained system, right? This one this part. So what we'll do, we will shift this. What will happen? Just draw what is written over here. Just draw like this. Okay, it was our structure. Then we had our this, and now this carbon will be attached to this only. There is one methyl, and positive charge will be here. So now what we are getting, the bridge is basically, this is bridge at carbon, this is bridge at carbon. 2 bridge, 1 and 1, 2 bridge and 1 bridge. So we are getting 1132, 221 bridge, 1132, 212, sorry, 221. The value, it is written in the chronological order, 321, like that. So 221 bridge, not 212. Okay. So now this, if I finally draw, this is nothing but this. Okay, if you tilt it in a little right side, okay, in tilt in little anti-clockwise in this direction, you will get this. So this is our carbocation. Now, is there any possibility of any shift or any ring expansion further? We will say no. It is 2-degree cation. It can be 3-degree cation if this methyl, this group shift here, but this will lead to positive charge on bridgehead carbon. This will not occur. Okay. And here, if hydrogens shift, then again it will be 2-degree cation. So no more stability we are getting. So this will not, again, no expansion, no rearrangement. So finally, water will attack. Yes or no? So water will attack this carbocation. Here, water. That means OH, OH group. So this will be our product. To be more specific, this OH position, exo or endo, which will be major. This will be exo1, like this. This will be major. Okay, because this endo side is steric hindrance is more. This side, this lower side in bridgehead position, there is more steric hindrance. There is steric hindrance of 2 carbon, but in the above side, steric hindrance of 1 carbon only. So exo OH will be major product here. Okay, so this is our discussion. After this, we are going to look upon types, different types of reaction, type of reaction with alkene, Now we are entering into reaction part, actual reaction part. Here we will see one by one. H plus water addition, HX addition, X2 addition, NBS addition, hydroboration oxidation, oxymercuration, demercuration. This will be alkene. After that, we are going to discuss, there is some special case of this. Okay, we're also going to look upon this. After that, we are going to discuss name reaction. Okay, name reaction. So in next video, we will start from this. Okay, till then, bye bye. If you have any doubt, let me know in the comment section. Till then, bye.